Finding equations of parallel lines with adamonlinetutoring. Here's the beginner question, one of the easier questions that you're likely to find on this topic. Parallel lines have the same gradient but different y-intercepts. They will never meet regardless of how far they are extended. The general equation of a straight line is y equals mx plus c, where m is the gradient, the slope of the line, and c is the y-intercept, where the line crosses the y-axis. If two lines are parallel, they have the same m, or the gradient. So finding the equation of the line that's parallel to y equals a half x plus 1 means I must have the same gradient of negative a half. And now I need to work out the y-intercept, which I can do by substituting known values for x and y that lie on the line. They've given me the coordinate 3, 0 to do this with. Substituting, 3 is my x part of the coordinate, and 0 is the y part of the coordinate. So when y is 0, this is equal to negative a half of the corresponding x value, which is 3, plus c. Simplifying gives me 0 equals negative 3 over 2 plus c. Therefore, adding negative 3 over 2 to both sides gives me c, which is 3 over 2. For my final answer, I can take the original equation, y equals negative a half of x, and now I've worked out that c is 3 over 2. I can add 3 over 2. On to the intermediate questions with an increase in difficulty. For the first one, are the lines 2x plus y equals 8 and y equals 2x plus 5 parallel? If the equations are not written in the form of y equals mx plus c, we need to rearrange them so they are. This helps us to identify the gradients. We can see that this equation is already written in the form of y equals mx plus c, whereas the equation of this line is not. We can rearrange to leave y by itself on the left-hand side if we subtract 2x from both sides. Therefore, y is equal to negative 2x plus 8. Now we can look for the coefficient of x, which is m, the gradient, and we can see that 2 is not equal to negative 2. Therefore, they are not parallel. For the second question, find the equation of the line parallel to x minus 3y minus 6 equals 0 and passes through the point negative 9, negative 2. Because it's parallel, I'll know the gradient's the same, but similar to the question before, the equation of the line is not written in the form of y equals mx plus c. I need to change it so it is. I'm going to add 3y to both sides. This will isolate the term that involves y and also make it positive to give me x minus 6 is equal to 3y. And lastly, to get y equals, I can divide both sides by 3. 1/3 of x minus 2 is equal to y. I'm just going to swap these round so it's written as y equals 1/3 of x minus 2. With it being parallel, my gradient will be the same. So y equals 1/3 of x plus c. I'll substitute the known x and y value of the coordinate that lies on the line. This will allow me to find my y-intercept, or my plus c part. When y is negative 2, this is equal to 1/3 of the corresponding x value, negative 9, plus c. Simplifying, negative 2 is equal to 1/3 of negative 9, which is negative 3, plus c. And adding 3 to both sides gives me c, which is positive 1. And rewriting the equation with my known y-intercept, y is equal to 1/3 of x plus 1. On to the advanced question, one of the trickier questions that you're likely to find on this topic. The point A has the coordinates negative 12, negative 7, and the point B has coordinates negative 8, 1. We need to find the equation of the line parallel to AB and passes through the point 2, negative 5. If it's parallel, the equation of the line will have the same gradient. I need to use the two coordinates A and B to find my gradient. I can use the version of the change in y over change in x or rise over run formula, y1 minus y2 over x1 minus x2. For the numerator, it's the change in my y values. It doesn't matter which one we start with here as long as we stay consistent. So if we start with negative 7 and subtract 1, for the denominator and my change in x, I need to use the corresponding x values to the y values that I started with. So if I started with negative 7, I need to start with negative 12. And subtract negative 8. This is where you need to be careful because you could end up subtracting negative values. Negative 7 take away 1 is negative 8, and negative 12 subtract negative 8 is the same as adding 8 to give me negative 4, and negative 8 divided by negative 4 is 2. Now the gradient is known, I can substitute this into y equals mx plus c. I need to substitute a coordinate that lies on the line to eliminate x and y and find my y-intercept. Again, this has been given to me as 2, 5. So when my y value is 5, this is equal to 2 lots of my x value, which is 2, plus c. Simplifying, 5 is equal to 4 plus c, and subtracting 4 from both sides to leave me with c, which is equal to 1. Rewriting the equation of the line with my known value for the y-intercept, y is equal to 2x plus 1. Since I need to write the equation of the line in the form ax plus by plus c equals 0, I can subtract 2x and 1 from both sides to leave me with y minus 2x minus 1 is equal to 0. If I subtracted y from both sides instead, I would have had 0 is equal to 2x plus 1 subtract y. Either of these answers are correct and would get you full marks. Here's a question that I've completed earlier. It appears as though I've made some mistakes. Pause the video and see if you can spot what they are before writing some corrections in the comments below.
Thanks for watching. If you found that video useful, don't forget to hit the like button and leave a comment. If you're struggling with topics or finding maths difficult, subscribe and turn on notifications to receive regular updates about new video tutorials and other useful content. You can visit and follow all of my socials by clicking the links in the description below.